Hey everybody, it's Mr. Canfield. Today we're looking at U substitution. So we talked about basic integrals, such as the integral of x to the fifth minus 2x cubed plus x. We also have things like this. So something like this, oh wait, this is right. In order to take this integral, we would normally multiply it out to get this. So in this situation, it's not bad, but with just a little doctoring, this becomes unbearable. So if I changed it to x times x squared minus 1, and instead of being squared, if we'd raised that to the 20th power, we now have an integral that is possible, but ultra annoying and not something that, there has to be a better way. It's not something we want to do. And it turns out there is a better way. So instead of integrating like this and multiplying it all the way out and then doing that, there is a way to essentially do like reverse power rule and reverse chain rule and that sort of thing. And we call it U substitution. So let's look at, let's look at his first example here. And he's got a really good sequence for how he does it. And I'm going to show my sequence the way that I do it. It might not look any different than his. So this first example here, it says the integral of 3x minus 2 to the fourth. So again, we could FOIL this all the way out and get some mess. But instead, if I could look at this as u is equal to 3x minus 2. Basically what I'm doing here is, instead of looking at this as 3x minus 2 to the fourth, I'm looking at it as something else to the fourth. So I can go, hey, instead of writing 3x minus 2 to the fourth, this is now u to the fourth dx. Oh wait, so here's the problem. We've talked about this before. The index of integration, this x right here, this is what lets us actually do the integral. If it's not the same letter as that, it doesn't work. So what we need to do is we need to take this and somehow make dx turn into like a du somehow. So what we'll do is we'll take the derivative here. We'll get du dx is equal to, what's du dx? Oh, 3. Okay. And we actually can separate this, multiplying both sides by dx. If we do that, it cancels out over here. And on the left-hand side, we have du is equal to 3 dx. And so if we look over here, it says u to the fourth dx. So all I need to do is replace dx. So if I want to replace dx, I just solve this for dx. And so I could say du over 3, or 1/3 du, is equal to dx. And so I can go in here and I can say, hey, instead of writing u to the fourth dx, I can write the integral of u to the fourth times 1/3 du. And then let's make this look a little bit nicer. And we'll say, I'm going to pull the 1/3 out front, right? Because it's u to the fourth times 1/3 times du. So we can say 1/3 times the integral of u to the fourth du. There's a lot of work, and I understand that. I'm trying to go through and show the nitty-gritty of how this works. It gets easier the more you do it. So now we're actually allowed to take this integral. So if we take this integral, the third's still out front. We add 1 to our power and divide by our new power. Don't forget the plus c. So we got 1/3 times u to the fifth over 5 plus c. So I can write this as 1/15 u to the fifth plus c. And we're almost done. The last thing I need to do is just say, oh, wait a minute, what was u? U was 3x minus 2. So we're going to say, oh yeah, 1/15 times 3x minus 2 to the fifth plus c. And I've bypassed any need to FOIL this out, and we're just done. And normally I won't do this in 1, 2, 3, 4, 5. I won't do this in 6 steps plus 4 more. Like, you can definitely shortcut here, but I wanted to show the full depth of what's happening for the first few examples. So let's move on to the second one. The second one says the integral of 5x plus 4 inside a square root dx. So we're going to talk about how we pick what u is in the future when we get to more complicated examples. For now, it's just this expression that we see. So we say, all right, u is 5x plus 4. And if I take the derivative of this and I get du dx, then we get 5. So you might notice that the next two steps are going to happen basically identically. I'm going to show them and go through them, but as you're doing this, there's nothing wrong with jumping to knowing what dx is equal to. So du is equal to 5 dx, and then dx is equal to du over 5, right? We're dividing by 5. So what I can do here is I can write the square root of u, and then instead of writing dx, I can write du over 5. So on my next step, I'm going to clean up a little bit before I take the integral. I'm going to pull the 1/5 out front, and I'm going to change the square root of u to its exponent form, u to the 1/2 du. And now we have legitimately an easy integral to do. We've got a 1/5 outside of, now u to the 1/2, we add 1 to that power. So that's 2 over 2 that we're adding. So we get u to the 3 over 2. And remember, then we're going to divide by that new exponent. And to divide by a fraction, you multiply it by the reciprocal. Plus c. So now I've got 2 over 15, u to the 3/2 plus c. And finish it up. Instead of writing u, we'll drop that back in. 2 over 15, 5x plus 4 to the 3/2 plus c. All right, so kind of all business right now. We got 16 examples to get through with these. All right, so probably won't do all 16 today, but I'm gonna go as far as I can. This is kind of our introduction to u substitution. It's a very powerful technique. So now we get to number 3. It says the integral of 4 parentheses 6 minus 1 all to the 2/3 dx. So with this one, you've noticed, or I don't know if you've noticed, I like to do my u work over here, and then I'll do equals and do my substitution over here. It's a helpful way to organize. So I'll say u is equal to, now let's pause. I see 6x minus 1 here. I see a 4 here. The thing that's the troublesome part is this stuff inside here. Because if this had just said x to the 2/3, I know how to do that. I add 1 to the exponent, divide by the new exponent. Since it says this big mess of 6x minus 1, that doesn't work anymore. And so we're going to make 6x minus 1 u. And then we'll take the derivative, du dx, and we get 6. And so we're going to multiply by dx, then divide by 6. Hopefully you see it's the same as before. It's going to be 1/6 du is equal to dx. So then when we go in here and we substitute, I can pull the 4 out front. I can also rewrite 6x minus 1 as a u, 2/3, and then dx we can replace with 1/6 u. Oops, sorry, 1/6 du. So I'll bring the 1/6 out front, and it's 4 over 6. All right, 4 over 6 is both divisible by 2, so we get 2/3. So 2/3 times the integral u to the 2/3 du. So this is a more reasonable setup for something like this. Now we'll leave the 2/3 there. We'll add the 1 to that. So it'll be u to the, that's 3 over 3 to 5/3 plus c. So final answer, 2/3, and then 6x minus 1 to the 5/3 plus c. So we're getting into ones where taking the derivative of this, we should end up with what we began with. So let me just test myself. Let me see. So I've got the 2/3 out front, and it's something to the 5/3. So the 5/3 is going to come out front. Oh my goodness. I'm glad I'm testing this right now, because I made a mistake. I made a silly mistake. Okay, sorry. 6x minus 1, then the 2/3. So we're subtracting 1. The c goes away. And when I simplify this, I wind up getting 10/9 6x minus 1 to the 2/3. So that's not actually what we started with. And the reason is I forgot here. When, oh my gosh. Wow, what did I do here? Oh, there was the, right. So there's the 2/3, u to the 2/3. Right, here, okay. With u to the 5/3, I should have brought out a 3/5. Right, we multiply by the reciprocal there. So there should have been a 3/5 here, which changes things. So if I were to multiply this by 3/5, we should see that stuff winds up working a little bit better. But oops. So so 3/5 times 2/3, the 3's cancel, we get 2/5. So 2/5, our u was 6x minus 1, so 2/3. Yep, sorry, 5/3 plus c. I was like, wow, I'm being really accurate today, not making any silly mistakes. And then there we go. So it is a good idea, especially on a test or a quiz, to kind of double check yourself. Hopefully I didn't make mistakes earlier. So the usual word we use for this is check. I don't know why I'm thinking test today. So anyway, if I do this and I try the derivative of this, I got a 2/5 out front. I'll multiply by 5/3. And then we've got our 6x minus 1. Subtract 1 from that. We have 2/3 left, and we'll multiply by the derivative of the inside, which is 6. C goes away. And when we do this and we simplify it, 5's cancel. Now there's a 2/3 left. So 6 times 2/3. We get a 4 out front. 6x minus 1 to the 2/3. So I got what I started with. So this is the integral of that. All right, example 4. Example 4 starts getting a little bit spicy. So, so 4, I have an x square root, x squared minus 2 dx. All right, you might be tempted to pull this x out front. X is not a constant. Remember, you can only pull numbers out front, not x's, not variables. So if I try this, I have to decide, do I want to make this u or do I want to make this u? And here's the big question you ask ourselves when we're trying to pick u. To pick u, whose derivative is present? And here's what I mean. The derivative of x is 1, and sure, 1 is present, but the derivative of x squared minus 2 is 2x. 2x is present here and is basically present here. You see how the derivative of this is going to be an x with a number, and there's an x. So my clue is that since when I take the derivative I get an x, this is telling me that this might be taken care of when I take the derivative of u. So what I mean is if I make u equal to x squared minus 2, well, this time du dx is equal to 2x. And when we multiply, we get du is equal to 2x dx. And let's see. And then we get du over 2x is equal to dx. When we go in and we do replacement now, and we get, just making sure it's visible, we get, let's see. Well, we have the square root of, oh, this is still x, right? The square root of u, and then instead of writing dx, I write du over 2x. And so now these x's cancel each other out. And that over 2 we can bring out front, and we can write a 1/2 out front, integral, and instead of writing square root of u, let's write u to the 1/2, just like we've done before, du. And now it took this really gross looking thing and made it look really, really simple. So 1/2 parentheses, let's see, that's going to be u to the 3/2, because we add 1 to it, multiply by the reciprocal, don't forget it this time, Canfield, plus c. And with some simplification, those 2's cancel, and we're left with 1/3. And then I'm going to write this as u to the 3/2, and u was x squared minus 2 plus c. So if I'm really checking my work, what I'll do is, I usually won't write it out completely, but I'll go, okay, the 3/2 comes out, you know, and you can, okay, I got the 3/2 out front, I got the 1/3, ooh, and I'm going to multiply by 2x on the inside, right, 2x. So I see the 3's cancel, see the 2's cancels, there's just going to be an x left over, and that goes back to 1/2. So I kind of like do a quick little sketch out of what's happening instead of rewriting the whole derivative like I did last time. So yeah, all right, I think we're going to do, I want to try to get up to number 8 maybe. Try to keep this video shorter than a ½ hour would be my hope. So let's see, 5. Let's see, 5 says, take the integral of x squared root 1 minus 4x cubed dx. Perfect example for us to talk about what we talked about last time. Whose derivative is actually present? The derivative of x squared is 2x. The derivative of this guy is negative 12x squared. So the derivative of x squared pops out of this, which means an x squared is going to pop out if I use this for u. So I'm going to say u is equal to 1 minus 4x cubed. We'll take du dx is equal to negative 12x squared. So when I solve this, I get du divided by negative 12x squared is equal to dx. So when I was first taught this, my teacher went even faster than this. You can do lots of shortcuts with these. It's whatever you're comfortable with. That's the level of shortcutting you're allowed to do. So when I do my replacement now, x squared is still there, square root of 1 minus 4x cubed, and we will replace dx with du over negative 12x squared. All right, just like what happened before, the x squareds are going to cancel, pull the negative 1/12 out front. Now I can write this as u to the 1/2 du. And so this is like great. That's so much simpler. It's going to be like the same problem as before, just with a negative 1/12 out front. U to the 3/2 times a 2/3 plus c. And then let's see, 2 and 12, we can get 1 and 6 out of that. So then 3 and 6 gives us 18. So we have negative 1 over 18. U to the 3/2 plus c. U was 1 minus 4x cubed. So really powerful stuff here. And then we reach the next problem. We look at 6, we cry, and we go home. X over the cube root of 2x squared minus 1 dx. We look at number 6, and we cry, and we go home. Yeah, this is like a keep calm and try u substitution. So, oh, I just made myself laugh. That was so stupid. Oh, I'm sorry. Oh, that was so bad. Okay, so at first glance, this looks terrible. But what if we said u is equal to the insides here, 2x squared minus 1? Well, then du dx is equal to 4x. And so we'll do the normal, multiply by dx, divide by this stuff. We'll get du divided by 4x is equal to dx. And so what we can do, we can go in and we can substitute. There's an x here. There's a cube root of u. And then there's a du over 4x. And you still might be thinking this is really, really terrible. You just give it like 2 more seconds. So the x's cancel. And we can pull the 1/4 out front. And I just want to remind you, this is actually really nice. 1 over the cube root of u. Well, the cube root of u is u to the 1/3. And what's 1 over something? We can change this to u to the negative 1/3 exponent. And all of a sudden, this thing that looked so monstrous is just really a 1/4 times u to the negative 1/3 du. And this integral we can do. We can say this is u to the add 3 over 3 to this, 2/3, multiplied by the reciprocal, 3 over 2, plus c. Lo and behold, we get 3 over 8, u to the 2/3, plus c. Everything falls apart. Let's see, so u is 2x squared minus 1. So, super simple. And that's it. Let's see. 7. Yeah, okay. I can use 7 and 8, and then I'm going to stop there. So 7 says square root, integral, sorry. X to the 1/2, x cubed, 3 over 2. I can't talk right now. Okay, I'm going to shut up. All right. Oh, just got demonetized. I'm not even monetized, I promise. I don't do this for money. I do this because I want to help. Oh, now that makes me sound like I'm a jerk. Look at me, I'm just trying to help everybody. I'm so nice. Okay, anyway, what's the derivative of this? It's going to be a 1/2 out front and x to the negative 1/2. I don't see that somewhere else, but I do see, ignoring the 3/2 out front, I see x to the 1/2 as the derivative of the inside, meaning we're going to make this our u. And there is a little bit of a pattern here. Oops, silly me. There's a pattern where, like, oftentimes the inside stuff is the best thing to take the derivative, or the best thing to make u. So du, one shortcut that people will do is they will, instead of writing du dx, they'll multiply the other side by dx in the first step. Like that. They're like, well, I know the dx is on the bottom, I'm just going to multiply it over here in the first step, and then we'll divide by this thing. And well, dividing by a fraction, remember, is multiply by the reciprocal. So I'm going to say 2/3 du over x to the 1/2 is equal to dx. So now when we go in and we drop it in, let's see what happens. The x to the 1/2 is still there. I haven't been able to get rid of it yet. But I can write u here, it's u to the 9th, and then instead of writing dx, we'll write this mess, 2/3 du over x to the 1/2. Hey, x to the 1/2, x to the 1/2. They're going to cancel it. Wow. We'll pull the 2/3 out front. Integral u to the 9th du. Remember, if it's not u and du, you can't take the integral. Those have to match each other. We don't know techniques in this class how to handle that. So 2/3 u to the, we'll add 1 to it, u to the 10th divided by the new power, divided by 10, plus c. So that's 30 on the bottom, 2 over 30. Oh wait, no. 2 over 30 is 1 over 15, right? We're going to say 2 and 2 cancel, we get 5, so 3, 15. Okay. Simply put, 1 over 15 times x to the 3/2 plus 4 to the 10th plus c. All right. Last one, number 8. 8 says x plus 2 times the square root of x squared plus 4x minus 5 dx. So, You might notice that if I take the derivative of this, I don't get x plus 2, but let's just see what happens. Let's use the big one on the inside. Let's say u is equal to x squared plus 4x minus 5. So then our dx is going to be equal to 2x plus 4, and then I'll bring the dx over to the other side. So in order to get dx by itself, I'll have to divide by this mess and get dx is equal to du over 2x plus 4. So now when I do my replacement, I've got this x plus 2. I've got, maybe you want to even write it a little bit differently. Maybe you want to throw the du over here, write the square root of u, which I'm going to rewrite as the 1/2 exponent. And then maybe we put the bottom over here, this 2x plus 4. You know, it's all being multiplied, so we're allowed to kind of rearrange. So if you're stuck here, and like this looks different than the other ones, yes and no. Think about the x plus 2, and then on the bottom, if we factor out a 2, what's left inside? All of a sudden, the x plus 2's cancel. We're left with a 1 over 2. So we can pull the 1/2 out front of the integral. We have a nice and straightforward integral. Excuse me. So we have our 1/2 out front, add 1 to the exponent, u to the 3/2, times the reciprocal, 2/3. The du went away, plus c. 2's cancel, we get a third. 1/3 this stuff to the 3/2 plus c. This stuff was x squared plus 4x minus 5. U substitution is so much about understanding the procedure that we're going through to replace to the point where it's a nice simple integral. It gets a lot more complicated than that. But if you get the basics of what we're doing, that we're finding a u, we're taking its derivative and getting dx alone, so that we can then go in and replace all the x stuff with u's and wind up canceling any other x stuff out. This is a super powerful technique, and looks like there's some real challenging ones to come, but this is a good start. So hope this was helpful. Bye.